Tuğberk. I specialize face recognition technology at Futurist, handled many projects around the technology, and did many talks around it. And whenever I bring people like the topic of face recognition, obviously the first thing they think about is the surveillance, the cameras, the artificial intelligence, the machine learning, this kind of stuff, right? But we're gonna get there. But before getting there, I'd like to discuss what is the current methodology that we use to recognize faces. Like, I would like to tell you first about the human vision, us recognizing faces, and then go there to the machine vision. So, human vision. It seems like we are overall a great fit for recognizing faces. Like, think about it. Interaction with other humans, it's our bread and butter. We do this day-to-day basis. We are conscious beings, we are emotional beings, so we have emotions like empathy, altruism, which we can, use to interact with spontaneous situation. Like, for example, if you're at the airport as a businesswoman who's late for the flight, a security personnel can give you a priority. A family who is a restless kid can be given priority as well. So we can use these emotions to make better judgments and answer the momentary needs. Also, we're great at recognizing the known faces. Now, when I tell this to people, people usually have this question of what is a known face? Let's dig into that. So, how many of you know this guy? Well, yeah, he is the famous Leonardo DiCaprio. Now I'm going to show you another picture. So, that's Leonardo DiCaprio too, and you guys knew it before I said it. So that's what I call, although like there's like probably 30 years difference in between photos and probably 30 kilograms, you still recognize them with a great accuracy. That's what I call the DiCaprio phenomenon. Just disclaimer, use caution using this term in public because it's something I made up. I just love the guy. I thought he deserved his own phenomenon. But yeah, anyway, so what does it mean in practice, like the DiCaprio phenomenon? It means that we're great at recognizing people we interact with frequently, celebrities, family members, significant others, neighbors, colleagues. So we are perfect at recognizing this people. And based on our success in recognizing those people, we assume we're great at recognizing people in general. Are we really? I'm not so sure. So, knowing that Mike Burden, a psychology professor at the University of York, set up an experiment in Australia and United Kingdom. And they created what they call a B-list celebrity data set, image set. So in Britain, they showed the British participant first, the British people, British local celebrities that are not famous internationally, but really famous locally. So they showed the British people first, and they recognized the British celebrities and matched them with great accuracy. When it comes to British people matching the Australian local celebrities, they failed. And not surprisingly, Australian people did the other way around. They recognized their celebrities with great success, but they failed to do so with British people. It is already surprising to me at this stage, but it gets better when you add some like confirmation bias to the mix. Because when these guys were asked, like the British people were asked, guys, what do you think? Which data set will be recognized for the rest of the world? British people said British celebrities, British local celebrities will be easier to recognize for rest of the world, whereas the Australian thought it's going to be the Australian celebrities. So it tells me that we are not only not so good at recognizing the people we don't know, but we don't also understand the underlying fact why we are not so good at it. And this is not the only bias like we're having towards ourselves. We have several other biases that we subconsciously experience. One of them is the bystander apathy, which is named after an unfortunate incident in New York in 1960s. So what happened was a New Yorker lady was killed in front of her house. It was New York, it was rush hour, there was a lot of witnesses, but nobody intervened. So when the police, of course this caught attention of the police as well, the investigator brought the people to the room and asked like, guys, why didn't you do anything? You could have like saved her. And they said, yeah, we thought it's an act from Hollywood. So if it wasn't, someone would have intervened and we would surely have followed. So you're going to ask me, how does this apply to this context? Since we're going to use a lot of airport stuff today. I'm gonna give an example from airports. So what happens is you know, at airport you have like 5, 6 checkpoints where you present your passport, identification, boarding pass, whatever. So if you are, let's say, the check-in agent, so you're the first one in the long chain of people who checks someone's document. So you subconsciously think that, okay, I'm the first person, but then there's going to be 4 other people checking this document. So if there's something wrong with it, probably someone will notice. And you're not aware of that. This happens like on a subconscious level. But the funny thing is, if you go to the boarding, so the last resort at the airport, right? The very last resort, if you ask them, like, what is your process, and then what their experience is, okay, I was the last person here. This passport has been checked like 4 times. So if there was something wrong, someone would have figured out until it came to me. So this brings us to the point. So we think that professionals like passport officers should be inherently good at it. They should be trained for it, right? So someone put this into the test. It's White et al. 2014. So basically what you see is the set of images that the passport officers and randomly selected group of students that has nothing to do with recognizing images, recognizing passports, gather together in the experiment. Here, let me see if this works. Well, it doesn't. So that's the target photo on the left. That's the 2-year-old photo. And the last one is the ID photo. The first one you see is the same matches. The bottom one is the mismatch trial. So these are not the same people, like the target photo and the 2-year-old photo. So I'm going to elaborate for you guys. Maybe it's small, but the passport officers barely outperform a bunch of random students at 75% accuracy. So this tells me that the systems that we're relying on are fundamentally unreliable. And it doesn't really stop there, because we're seldom given the task of recognizing faces only. A passport officer needs to also check the biographical data presented in the passport. So of course this was put to test as well, and the result was really interesting, because what happened was, if the passport information, if the biographical data was correct, it introduced a bias towards the same answer. So basically, when we checked the information, we got that, okay, this is a valid passport information. The passport officer tend to say that this image belongs to the person in front of me, whereas it wasn't. And that's still not the only thing. We have time pressure as well. So one of the most important KPIs for passport officers is time. Just to give you a perspective, 95% of the UK passport officers needs to process 95% of EU and EEA passports within 25 minutes of joining the queue. Australian passport officers need to process 92% of all passports in 30 minutes. So they can't take forever. And we already know that we are struggling to make any decision at the time pressures that are 4 seconds or low. So what do I mean? I mean that we have our pros, right? Recognizing faces, but we have also our shortcomings. And that's where machine vision can come into play. I'm going to explain a bit more detail what machine vision can do for us, how can it help us make better judgments, but let's do some quick benchmarking. So iPhone X, I had to mention it because iPhone did it and it created a big hype, but I was doing basically something similar with my OnePlus One in 2014. But yeah, so the idea is that you can unlock your phone using the Face ID camera that they have. You can pay now with it. Also, you can set poop emojis that again talk. Amazon Go, probably you've heard about it. It was really revolutionary when it came out. So basically, you go to a store. There's a lot at play here: machine learning, IoT. You go in, no lines, no queue. You just fill your bags and you get out. Alipay, Smile to Pay. This was for KFC. This was based face that gather face recognition and emotion recognition together. You go there, you look into camera, you smile. It first recognize your face, and then analyzes it if you feel happy, and then proceeds to the payment. But I gotta give it to the Chinese people. Like this a brilliant idea, because you know how like the smiling occurs, right? You experience a sensation, and then hormones kick in, and the physical reaction is to smile. But then it was shown that you could actually reverse engineer that process. So if you force yourself like smile long enough, your brain starts to think like, oh my God, I'm missing on something. So like I need to rush these hormones in, and then you start feeling happy. That's like quite a superficial process. But then this is like perfect case for the service provider. It's like they experience it and you go ask them like, I don't know, I feel happy. It's perfect, it's good. So machine vision, quick summary on that. It's precise, it doesn't have biases, no cognitive overload. It works 24/7 except for downtimes, but you can always blame your developer for it. It enables zero UI identification, meaning that you don't need to key in anything. You don't need to swipe your card. You don't need to show your boarding pass. You just walk straight, and it's done, all done in the backend. But then, of course, there's cons. Like when the experience is designed badly, it's a problem for the customer. A good experience is what they did in the London Heathrow airport. They basically set up a face recognition system at the security at the fifth terminal. So what you needed to do is you go there, you scan your boarding pass, you scan your face, and then you compare it when you board on the flight. So you know how congested Heathrow airport is and how problematic the whole security is in there. So basically you introduce another step that will make the customer's life miserable. And also other problem is that it's binary. It deals with ones and zeros. So that means that it can't handle like spontaneously arising situations. What is the solution? The solution is gathering human and machine together. But I can tell you that we haven't rehearsed this slide with Daryl, but yeah, it's the common sense. We need to gather human and machine together to get the best out of both worlds. So we are good in making conscious choices. We are good at correcting machines like lack of perspective. And machine is good at, fast, accurate, pattern-based prediction and classification. The second golden rule is, as a wise guy once said, you have to start with the customer experience. So if you're going to use a face recognition technology, in your case, you still need to understand the process that you are integrating face recognition technology into. So, how it works. Let's dig into that. So you need to basically tell the system, like you need to register someone so that it could be recognized, right? The first step is, from the customer point of view, is the enrollment. So you need to enroll them to the system. And the second step is to go wherever the recognition area is and have them recognized. Whether it's the enrollment or recognition, the process is the same. So we grab image from the source. We detect the face. That's the most exhausting part in the process. Then we create the landmarks. We determine the landmarks belong to that face, 3D mesh fitting, and then some pre-processing, extracting the features, and you have your biometric ID. You don't even need the image after that point. You created a vector map for you to use in the recognition area. Let's get into some hands-on examples. So let's try to design some cases together. So this is a restaurant case, really simple entry-level hospitality kind of application. So this restaurant wants to, give a special treatment for their loyal customers. A small gesture. When they enter the restaurant, they get ready the special beer or cocktail, whatever it is. They want to make it ready so that when they go to the bar, it's ready. They just pick it up, they go sit wherever they want to sit. And we know that they have like 100 frequent customers, and they visit once a week. That's the case that we have had. So, the system elements. We have algorithms, we have registration tools, we have recognition tools, and we have the server database decisions. We have tons of algorithms out there, commercial ones, really expensive ones, the ones that likes the frame images over video stream images, the ones that are open source, the ones that are cloud-based. So all of them out there, available, and waiting for you guys to determine your case and go talk to them. In this case, we have a really small case, 100 people, 100 images in the database, maybe 200, 300 if you want to be really sure, but still it's a small case. And we are talking about like 400 times because they're visiting every week once. It means like multiplied by 400 transfer requests. So in this case, I would just go for the open source one. Because even like there is a misrecognition, you confuse someone with someone else, the cost is 1 beer. So you don't need to go to the most advanced algorithm and pay like 100,000 euro in advance to get most advanced solution that is working 7/24 without any problems. And then registration tool. You know that these guys visit you every week, right? So just have a webcam set up, and whenever they're here, if they are willing to, of course, you need to ask them first, just register them on the spot. And since you want to recognize them as they enter the place, so it's kind of on the move, I would get an okayish camera. It's a single unit restaurant, so they have no interest in scaling the business up. So I would just have a PC running in the back office, the whole system. Let's get into a more demanding one that involves money, because that makes this funnier. So you guys have 7-Eleven here. It's kind of like, in Finland we have the R-kioski. Basically it's for everything kind of shop. You go buy bananas, chocolates, gums, subscription for your phone. You can load your passport, and at the same time you can have coffee. And in this case, say the coffee machine is further apart from the cash desk. So what happens is, in the morning, there's people who purchased 10 coffees through the app. They go take their coffee, and then they come, queue in the line, and wait for 5 minutes to show the receipt that they have purchased the coffee, although they are done with the process, both payment and claiming of the coffee. So the solution is to actually apply a face recognition solution next to the coffee machine, where they can redeem the coffee. So in this case, I would spend a little bit money, right? Because this is like a payment case. Although we're talking about like one coffee, it's 1-2 euros. Still, it could cause you bad PR. So I would try and spend a little bit more and get a sort of advanced algorithm. Still, I wouldn't go for most advanced one, because since you are saving a lot of time for these customers, like we're talking about 5 minutes, 3 minutes, you can have them like stare into camera, the webcam, 1-2 seconds. So you have enough sort of frames to fix for your mistakes. You can compensate it for the user experience. And these guys already have the app. They purchase the coffees through the app. So just add a face recognition feature, and then the photos are sent to the database. The recognition tool, I would use a webcam because the environment is controllable. The illumination is similar all over the stores in the country. And server, since this is a kiosk, there's gazillion of them in the country. I would go for a cloud server. So the next case, face recognition premium service at Helsinki Airport with Finavia and Finnair. This is an actual case we have done with Finnair and Finavia back in May, and the idea was like focusing on human interaction and convenience. I remember, like, it was 2 years ago. I met Eero at the airport, and Eero is the head of service development at Finavia. So our first conversation was based on how can we make our frequent flyer customers more happy, like or give them more privileged services. So one of the ideas was basically, since these people are easy to reach for us and they are willing to get this kind of extra services, we decided to give them a little bit sort of premium experience. And instead of getting a 30K a piece face recognition kiosk, which is kind of, if you know about the experiments around Europe or world about face recognition, there's like this face recognition kiosk where you need to go, you derail from your original pad and you register yourself. We deployed an app, and with 3 easy steps at their comfort of home, they provided us the photos that we needed. And we had a dedicated check-in desk for them. This was a proof of concept, so we had a single touch point. So what they did was they just walked towards the line that was separated for their purpose, for their use. And when they move towards the check-in desk, we already know them, and we presented them with the boarding pass for the later phases of the experience. Before handing it over to Eero, I'd like to share the video. Basically, it shows like how the experience was and what was the customer feedback. We are at the Helsinki airport. We're testing the face recognition technology. Passengers are asked to register themselves using the Android app we developed for this purpose. They are going to register 3 images of themselves, which is going to be turned to untraceable biometric IDs. and then they're going to walk down this way, end up in front of the check-in desk, and have themselves recognized.
Tämä oli yllättävä, mielenkiintoinen, helppo.
Joo. Ja käyttäisitkö jatkossa?
Kyllä, mä käyttäisin, joo.
Mä koen sen tosi näppäränä, että sit kun sä oot siihen rekisteröitynyt ja jatkossa näin, niin kyllä se tosi paljon nopeuttaa ja tosi simppeli. Joo. Ettei tarvitse paperit kantaa.
Kaikki mikä helpottaa tässä vaiheessa, ne on aina odotusajasta pois.
Hyvä, kiitos.
Kiitos.
So yeah, it makes a lot of difference when you put the customer experience first, even if you use technology like face recognition, which is for some deem it as evil. It makes a lot of difference, and it brings another level of acceptance. Thank you very much for listening to my presentation.